Alright, so we're going to write the rule for each transformation. And when we do this, first we've got to decide what happened to it. Because we've got 4 options. It could be a dilation, it could be a translation, rotation, or a reflection. So we need to first look at our shape. So let's look at number 1. Alright, here's our pre-image, the one without the tick marks, and here's our image, the one with the tick marks. If you look at it, the K is still on the left side of both, the N's still on the bottom, L's on top, and M's on the right. So it's still the same exact thing, it just looks like it slid across the page. So this would be a translation. So that's what type of transformation, but that's not the rule. That's just telling me what it is, but I'm going to write that so I remember. Okay, this is going to be our arrow. We'll put a little star by it. Arrow or function notation. Let me see this word somewhere. Arrow or function notation. Either one of these, they mean the same exact thing. It's just 2 different ways you might see it, okay? Alright, so that would mean arrow function notation means you start with x, comma, y, because your pre-image, those are your points that you start with. They are x and y. Something happened to those points to make it this new image. So we start with these and we transform them, so we use an arrow, that's why it's called arrow notation, into a new point. And when you did the lessons last week, they give us this sometimes and they tell us what it is here that we've got to do. So we're still going to have our x and our y, but something is going to happen to them, okay? So we need to look back up here and see what happened. We started here and we went to the left. We went left 1, 2, 3, 4, 5. We went left 5. We didn't go up or down any, we just moved to the left. So left and right is my x-axis, so I'm going to do something to this x value. If I go to the left, if I start at a 1, that's my x value here, and go to a -4, I would have had to subtract. So I'm going to subtract 5. That's x minus 5. Y value, I didn't move up and down, so nothing's going to happen to my y value. So we just write comma y. Alright, this is arrow notation. Just like you saw, but now we're working backwards. Alright, the next one, let's see about this one. Alright, we've got our image, our pre-image, and our image. G, G prime, I prime, H, H prime. So let's look. We got G on the left, and G is still on the left. I is the ones on the bottom, H is still on top. So we didn't turn it around, we didn't flip it over. We kept it the same. So that just means we slid it across. So this is another translation. Translation. So let's see how we went. If we start here, first we go left. We went left 4. And then we went up 1, 2, 3, 4, 5. And up 5. Each point. Left 4, up 5. Left 4, up 5. So this is what we're going to use when we write down our arrow notation. We have x, comma, y. Draw your arrow. So it transforms into x. Alright, x went to the left and left. So go from a 4 to a 0, we'd have to subtract. So it's minus 4. And then y, we went up 4. So to go from 0 on the y-axis all the way up to, not 4, up 5, all the way up to 5, we're going to have to add 5. There's our function notation. Pretty simple. You should have to think about it, but it's not really that hard. Alright, next, number 3. Let's look at this. Alright, so pre-image, image. Q and Q are still on the bottom. R is on the top, and it still is on the top of R prime. But at first it's on the left side, and then it's on the right. Okay, T started out on the right side of this pre-image, and it moved to the left side of the image. So it seems like it kind of flipped over. When we think of flipping, that's a reflection. Okay, this is a reflection. So now we've got to decide, because we can't just say reflection, it had to reflect over something. We've got to see where it reflected. So the way you do that is you meet these points in the middle. So R and R prime jump till you get to the middle. You can check with other ones. And this one's pretty simple because the S is in the same spot. And if it's in the same spot, that means it was on the reflection line, or the line of reflection. So now we've got to decide what that line is. Because we reflect across. Let's see what this line is. Okay? So we crossed over the x-axis, so we know this is going to be an x equals. It never touches the y-axis, so it's not going to be y equals something. We got to see where it crossed the x-axis at, and it crossed it at -1. So it's a reflection across x equals -1. You can't write arrow notation for this one because there's no way to do that. Okay? Alright, now look at this one. T on the left, T on the right. S is still on the bottom. U was on the right, now it's on the left. Okay, so that means this one flipped over again. It was here and then it flipped over. So we got to find our line of reflection again. So jump to the middle. You can find exactly the line it flipped over. So this was a reflection. So we're going to reflect across. We're going to name our line. So this line crossed over x, so we know it's going to be x equals. It crossed over it at -2. So it reflect across x equals -2. Last one, 7 and 8. Well, let's look at these. These are going to be the trickier ones, okay? So let's look at this one. Let's see if we can figure out what's happening. Didn't change size, so it's not a dilation. First we've got y on the top, and then now y's on the right side. Well, that didn't make sense. It didn't flip. It didn't flip over anything, and it didn't just slide, or y would still be on the top. So that leaves a rotation. Okay? So rotation. So we got to figure out, because we can have 90 degrees clockwise, 90 degrees counterclockwise, or 180 degrees. Well, don't just guess. I mean, y'all probably can figure them out sometimes, but there's a really simple way to do this. Okay, remember, when you rotate, we rotate around a fixed point. So we're going to rotate around our origin is where we're rotating from. Okay? Then let's pick 2 points. Let's go with y and y prime. I'm going to connect these points to my origin. So I've got y, and I've got y prime. Okay? When I connect these, I made an angle. What type of angle did I make? I made a 90-degree angle. Okay? So right angle, which is 90 degrees. So I know it's going to be 90 degrees one way or the other. Now I got to decide if it's clockwise or counterclockwise. Remember, clockwise goes around this way. Counterclockwise goes backwards. So start with your pre-image and go the shortest distance. I'm not going to go way around this way to y prime. I'm going to go from here all the way down. And that's the same way as a clock. So I'm going to rotate 90 degrees clockwise. Okay, so I went that direction. I'm not going to go all around this way because then it's not 90 degrees. Okay, alright, this one, let's check. First I've got G on top, G on the bottom. Okay, then I've got F on the side, on the left side, F on the right side. Well, that doesn't really make any sense. It didn't flip down because it would be somewhere right here. And I'm just having one transformation happening. It didn't get smaller, so this is another rotation. So again, connect your points to the origin. So here's my origin. That's what I'm going to rotate around. I'm going to go with F this time. F to the origin and to F prime. Alright, this time I made a straight line. What type of angle makes a straight line? 180 degrees. A straight line's 180 degrees. And it don't matter if you go clockwise or counterclockwise, you're still going to go 180 degrees. So this one is rotate 180 degrees.